So I want to talk today about Kubernetes node set, an idea that Kubernetes can manage its worker by itself. So currently, you still need some other tools to manage the nodes, and we come up with a concept or a POC to show probably how it would be possible to completely manage nodes inside of Kubernetes. So who I am? I'm Sebastian, one of the founders of Loodse. We started around about 2 years ago. Before that, I was part of the SAP. I worked 7 years for SAP in different areas. And when Google announced Kubernetes, we said, okay, that's an interesting tool. We want to work with it. Let's build a company around this. And so we started Loodse. We are from Hamburg, so we say, okay, let's stick to the ideas of Docker and Kubernetes, helmsman of the ship, and we find the lower German word Loodse, and say, okay, probably a cool name for a Hamburg company. And yeah, our product is called Kubernetes, and we are also a Google Cloud partner, working closely with Google, helping customers to implement their solution on the Google Cloud platform, train customers on Google and on Kubernetes. And we are also a member of the CNCF and Linux Foundation. So we built a Kubernetes container engine, and the idea was, when we started, we built it for different customers, built the idea, okay, how to run Kubernetes, and when we are on the Google platform, it was every time totally easy. We press a button, we have a Kubernetes cluster. But when we work with other cloud providers or it was every time hard, especially when the customer wants to have more than one cluster, wants to have update. And so we come up with an idea, okay, we want to have something similar to the Google Container Engine, but not working on Google. And we also want to support different cloud providers. So, quickly show how it works. So the idea is really, we want to press a button, we want to give the cluster a name. We want to select a data center where everything is running and create. And now we're spinning up the master, and everything should be run automatically. And it takes now roughly 1 minute until the master component up and running. But that's only the half part of the story. So having a master, it's probably the harder part, because you must deploy so many things like API server, scheduler, etcd, but now we also need nodes. And initially, we start with the idea taking the APIs and call it. But there are also different implementation available. So to set up node deployments, you can use Puppet, Chef, Ansible. You can use Terraform, Bash script, like we, using the API, using Google Container Engine or some services, kops for AWS and Azure. But all of these approaches every time has some domain-specific knowledge. And the Terraform is only an example in this case, but it's more or less valid for all the tools. So you have your Kubernetes cluster here, but to deploy nodes, it's somehow out of the cluster. So when you're coming more from the developer perspective, who wants to deploy applications on top of it, for scaling the cluster, you every time need ops, and it is not so native for a developer. And there's also no generic approach. So Ansible is different from Terraform, AWS is different from Google. So each implementation needs some domain-specific knowledge. And scaling a node also needs some external dependency, depending if you're on the cloud provider or not. Like AWS or Google, you can use the autoscaling groups, but when you're working on DigitalOcean, they don't have this concept. So you're not able to do autoscaling of nodes in total. And it's also, if you are on one platform, it's hard to go to another platform. Also, when you're using things like Terraform, more or less a complete re-implementation. Or even more, if you're using things like kops, there is no kops for Azure or Google. So then you build up something completely from new. And when we started implementing, because we want to implement as many cloud provider as possible and as easy as possible. So we said, okay, probably every time implementing the API could not be the right way because it will make a huge effort, and we want to streamline this because it don't feel native. So we looked in Kubernetes and looked at the system volume. So where you have a general approach, as a developer, you don't care what's underneath. You claim your volume, and you have a storage class, and then something happens, and you can have different implementation for different storage layers. So there are implementation for Google, for AWS, for Zeph, for GlusterFS. But from the developer perspective, you don't see it. You say only, I need a storage cluster, or I need storage 10 gig, and attach it to the node. So we were thinking, okay, we want to have something like this for nodes. So we come up with the idea and said, well, we want really a native integration so that dev easily can scale a cluster. Also thinking about this pets versus kettle approach. So currently, all of this solution somehow feels every time like the node is a pet. You try, hope that it's not gone, and otherwise try with the script to get it up. But it should be like a kettle. You should throw it away and get easy a new one. We want also have a generic approach to the autoscaling. We don't want to rely on the cloud providers. We want to have this for cloud providers which don't support this. We want to have this for bare metal. So even to scale cluster, when you have separate clusters, to scale the nodes between or the nodes between the cluster. And it should be very similar for different providers. So it should not be every time, okay, I want to integrate a new provider, going back to the roots and implement it completely from scratch. So at the end, what we want is something like kubectl create nodes, and then something happens. So and then we looked at how can we do this, and I mean there is already a node object in Kubernetes, but the node object is somehow used different as many other objects. So like for deployments or something, first you create first something, and then something happens. But for the nodes, different. First, something happens outside of Kubernetes, and then the node object is created. And we were asking ourselves, could we reuse the node object and create it first, and then something happens, and do something? So what we did is we use the node object, the standard Kubernetes. Oh yeah, sure. Good point. We use the node object. We specify a name, specify an annotation for a node class, which we see later what this is. Specify, for example, a controller which creates this, and some information like operating system and the host name. And then something should happen. And what is this? Who is doing this? What we want is a node controller. And this should be something really independent. The node controller watches on nodes when a new object is created, and then starts the provisioning of the node, and created the node so that it can join the cluster where it belongs to. It can also update, when you update the node, it will create a new node and remove another one. And you can delete nodes when you delete the node object. So really like if you're doing it with pods in Kubernetes. But the idea is, we started, or we're currently implementing this. We were looking around, okay, what would be a good implementation? And we saw, okay, there's Docker Machine. And Docker Machine is a great library which already implements 20 or 30 different cloud provider, and it's easy to add your own driver for it. So we stripped down a lot of the Docker Machine part and only use a small part of the provisioning part from Docker Machine and build a controller around this. But the concept we want to provide here is not in that way that everyone must use Docker Machine or the library of Docker Machine. So if you want your own node controller, you can build it. The main point is it must watch on node resources and provision this information. So you could provide or implement a node controller for Terraform, or you could even create a node controller for Python, which then calls some Ansible script. So make this really generic, like the storage class, so that you easily can build your own controller and manage your nodes. And We want to have a generic node controller, but when you want to have, for example, when you say, no, I'm only on AWS, and our focus is really only concentrating on deploying the nodes, and we assume everything else is created somewhere else and provides this to the nodes. But when you say, okay, I want a much more richer node controller, which know all the specifics of AWS, then you could implement your AWS specific node controller. But from the developer perspective, it's every time same. So they only do kubectl create node and something happens. But some informations are missing. So like, where do you provide cloud provider or OS specific details? For this, we want to use node classes, like the storage class. Here you provide like your cloud provider credentials, what type of machines, your provisioning files, SSH key, SSH commands. So let's look at one. So here you see it's a third-party resource. So in this type, you specify, okay, this is a node class. You specify your node controller. So also in the same cluster, you could use different controller. Probably you also have an infrastructure controller who do something else. You provide your DigitalOcean IDs. You provide your ASH key. You provide your SSH commands, some certificates, and then you provide your systemd unit files. And this is connected with the node. So here you find our node class. This is the reference to it. But connect both together.
Can you actually, can I ask?
Yes.
Yeah, can you connect this with the horizontal node autoscaling mechanism, or have you done that already?
Wait for the next slide. The next thing is, because it's not every time a one-to-one relationship, we need something more. So we want to introduce a node set. A node set is a group of similar nodes. So normally you not only deploy one node, you perhaps deploy 10 nodes from the one side and 10 nodes from the other side. Probably 10 nodes with high memory and 10 nodes with high CPU, perhaps. Or you only deploy the same nodes. And this should be then integrated with a node autoscaler. So that the node autoscaler, instead of a specific implementation for AWS or Google, it looks at the node set and change the replica count. And the specification, it's quite easy. You have the replicas, number of replicas, you have the name of the node controller, and you have the name of the node class. And then additional, you have a node set controller, similar to the replica set controller. And at the end, what the node set controller is only doing, it's looking if the numbers which are specified in the node set are equal to the nodes which are on the system. And with the integration then of the autoscaler, you can automatically autoscale your cluster without depending on any cloud provider specific implementation. So you are completely flexible. So now it's demo time. Let's have a look at it. So in the meantime, because currently we are heavily in development, we have already most of the things done, but some parts need some manual steps. I already created a cluster with, we have two possibilities. One is we can create the cluster directly in the UI and create it, or we will do the manual way. So we want to create a new node here automatically and automatically assign it to the cluster. So what we are seeing here, big enough, okay, is a log from the node controller. And what we want to deploy is node number 3. So we have defined the name, the host name, operating system, and everything. And now, let's say, kubectl create node, send it to the API server of the cluster, and now it's creating. And now we see the controller picks it up and starts a node. So when we now go login. Okay, will take some. I can't show you on DigitalOcean, somehow they block. But
and the node is the same data center because you have specified that.
Exactly. So because everything is specified in the node class, like also the deployment information, what information the kubelet need. So what is what's the API server? Here you find our API server URL. What's the API server talk to? We provide a token to the kubelet so that it's automatically doing the TLS bootstrapping and so on. And yeah, what we are doing is the node controller has implementation of the library of Docker machine. This calls the DigitalOcean API, sends over via SSH commands the files and yeah, some SSH commands, and then it's starting up. And we see already, okay, now it's red. When we go in. We see now, I should show this before it was undefined. Now it's already not ready. So the machine is already started. The kubelet is already contacting to the API server, and now it takes some time until the kubelet is doing now some health checks, like do I have enough CPU, do I have enough memory, disk, and so on. And as soon as this is provided, we will see it automatically ready here, and then I have a complete running cluster. Additional to this,
and you're just reusing the node kind which is already there and augmented it.
Yeah, exactly. So we're using the node class which is already there and have the link to the node class and provides this. And the node controller knows how to match this together. And additional, when we do get pods, we deploy everything with daemon sets. So automatically Flannel is deployed as daemon set. Node npm node health check. I don't know how it's called correctly. The kube proxy is deployed, and now we should also see. Takes a little bit more. At a certain time, it will come up and will be ready. And now I can easily create hundreds of nodes and yeah, scale this up, scale this down. I could also do. Delete node, and now it's already gone. And when we're looking at the log, it starts deleting this node. Here you see node 1 does not exist anymore.
So when you create, we know about the master, how do you get it? And if you have two masters, or one is down and changed up.
This you must provide in the node class. Here you would specify like what is the server you want to talk to. So when you have an HA set up, you must specify both servers or do a load balancer in front of. In our case is like running hundreds of cluster. We generate this. So when we deploy a cluster, we automatically generate these entries, how it should talk to, and then we know, okay, exactly. Also, when we create two nodes for different clusters, they exactly know to which API server they should talk.
But this is for the case where you have big the cluster. If I want for your big
yes, you only must provide, like in this case, you would provide your kube config with the API server URL and the token so that it can connect, and that's mainly it. And then you can customize depending how you're running on which operating you're running. We're running on CoreOS, and we use CNI for networking. So depending what you're using, you must specify this or set it up. Yeah, depending on this. So you could add some more unit files, for example, for your networking also. In our case, it's easy because we don't must deploy anything. We automatically, when a node is deployed, the daemon set takes care and run everything. We only must ensure that the CNI plugin is installed on that machine. Hopefully. Yeah, now we see both are ready. No, we don't want to do in-place updates. So what we want to do is, currently we have the node controller implemented. We currently work on the node set controller, and the node set controller should take care about updates. So then I would specify a new node class with like a higher version of the kubelet, and inform the node set controller, and then it will create new nodes and remove the other one, like you're doing with pods also in Kubernetes. So we try to avoid in-place updates every time, add and remove. And we would do this, or we also have an implementation for bare metal. The only requirement is that you have minimum one node which can go out of the cluster. Yeah, that's mainly it. The idea is we are currently working on this, and we don't want to do this on our own. There's a project on GitHub, kube-node, and here you find the specification for the node set and our implementation of kube machine. So feel free to test it out. And of course, it's not only me and us. There are some more people working on this. On the one side, two guys from China, Russell and Ivan, are working on this. Stefan also sometimes supports us with the implementation. Yeah. And of course, if you're interested in working in this area, we are from Hamburg. So, and if you are living around in Hamburg, but we don't care in total, we are looking for people, of course. Let us know. And yeah, feel free to ask questions now.
Question back to the autoscaling mechanism. So if we see that there is basically a resource event as a bottleneck or can be scheduled, do you have mechanisms to identify that which kind of class automatically should or which kind of node should be spawned up? Like if there's a GPU pod which is actually required, or do you have some thoughts about that?
No, not yet. What we want to integrate is like the node autoscaler, but we haven't. Here it is. Here we want to integrate this later, but because here you have different cloud provider implementation. And here we want to integrate our own implementation, but we are not there yet. We are currently working on the node set, so get this everything done, working on updates, and then the next step would be autoscaling. And first of all, we would follow the rules, how they are doing it with AWS, Azure, or BCE, and then probably thinking out special cases.
And is there a chance that this is going to go upstream in core or Kubernetes repo itself?
Yeah, that's one of the reasons why we make this open source and under the Apache license, because we think there are currently intention to make a cloud provider specific operator, but everyone behaves different, and we don't like this idea. We want to have something really generic, and we are in discussions with the core people. The intention is now first doing a POC. Show that the POC is working, then put this in the SIG lifecycle group, open for discussion, and then we will see if we can, how close we can get this into the core, or if you can completely get this in the core. What we don't want is like that that this is required for Kubernetes. So it should be every time optional, because when people say no, I have specific requirements, I want to use Terraform or whatever, they should able to do this. But for people who say, okay, I want to use this tool, it should be easy to deploy and easy to run this. We run this as a deployment on a cluster. So you only deploy this on the cluster, specify the API server which it should talk to, and then you can run it. Ideas is also like integrates this with things like Bootkube. So for example, that you spin up one master and then deploy this on it and say, okay, I need a 10 node cluster, going for a coffee and coming back and everything is up and ready. Further questions? Cool, then thank you.
Thank you.
Hope you enjoyed it.